Okay, this lesson is 1.7b of inverse relations and functions, and we are dealing with the second objective. So in the first part of this lesson, we've used the horizontal line test to determine whether or not a function had an inverse. And if the answer is yes, then sometimes we want to find that inverse, or we need to find it algebraically or graphically. So we're going to start off with that, and we're going to go do some of those. So remember, if it passes the horizontal line test, it's 1-to-1, okay? But the important thing about an inverse function that I really want you to remember is it undoes a function. They undo each other. So if you start with x, or you start with a number, let's start with x, and you put it into a function and you get something, and then you put it into the inverse, which undoes what you just had, then you're going to get back to x. Okay, in a little more simple terms, if addition and subtraction undo each other. So if I took a number and I added 5 to it, I'm going to get another number. But then when I do the inverse of subtracting 5, I'm going to get back to where I started from. So that's kind of a key. If I have the point AB, then I'm going to have the point BA, because I'm going to get back to where I started. Okay, so 4 basic steps to find the inverse of a function. First, we're going to see if it passes the horizontal line test, because if it doesn't, we don't have to go on. Number 2, we're going to replace f of x with y and then switch the x and the y. Then we're going to solve for y and replace it back with the correct notation. And then last but not least, we're going to find out if we have any restrictions on the domain. So let's go do those. Okay, so first off, we have, I'm trying to come down a little bit. There we go. Determine whether f has an inverse function. If it does, find the inverse function and state any restrictions on its domain. So as I just said, it's a 4-step process, and I'm trying to make sure I get all the steps in. So first and foremost, we would graph it. Use a graphing utility, go look at the graph. So I have f of x equals -16 plus x cubed. So if I go graph it, that's what my graph looks like. Okay. Does that pass the horizontal line test? Yes, it does. So since it passes, I know it has an inverse function. Okay. So to find that inverse function, I'm going to first off replace f of x with y. And after I do that, then I'm going to switch the x and the y. Okay. And then I have to solve for y. So to solve for y, I'm going to add 16. And then I'm going to take the cube root. So that is the cube root of x plus 16. And then the last step of it is to make sure that I replace y with f inverse. I don't know what happened there. Anyway, there we go. F inverse of x equals the cube root of x plus 16. And then the last step, I have to figure out, are there any restrictions on my domain? So some of y'all can do this, so I'm going to encourage you. Can you take the cube root of any number? Is there any number you can't take the cube root? You can do anything. So there are no restrictions here. If you don't know that, then you can go graph that function and look at the domain and look and see. And I don't know why that keeps happening, because I didn't turn off my messages. Anyway, so there are no restrictions on the domain this time. So that's our final answer. Okay, 2b, f of x equals x plus 7 over x. So what do I do first? Graph it. Does it pass the horizontal line test? The answer is yes. So I'm going to replace f of x with y, and then I'm going to solve for y. And a lot of people forget, but if you think about putting this y over 1, then you're just going to cross multiply. Actually, I'm sorry, I didn't switch it. So you got to switch first. Switch the x and the y. Now we're going to cross multiply. And if I'm solving for y, I have to have them on the same side. So I'm going to subtract y from both sides. And this is the challenging step. So put a star by it in your notes, or remember, because people always forget this. And that is, I have to factor out the y. So when I factor it out, I get x minus 1. Y times x minus 1 equals 7. And then I'm going to divide by that x minus 1, because to solve for y means I'm getting y all by itself, y'all. So it looks like that. And I'm going to replace the y with f to the negative 1 of x, or f inverse of x, and that would be the answer. Now, are there any restrictions on my domain? Well, back here on number 3, we did have to be aware of radicals, but we really only have to be aware of them if they're even numbers. So that's why that one was not a deal. We have to be aware of fractions, and I do have a fraction. So what makes that denominator 0 is the number 1. So remember plotting that. We've done a lot of that, so I hope this is easy for you and you can see it coming. But x can't be 1, which means it's everything on the number line except for 1. So I'm going to go from negative infinity to 1, and then 1 to infinity. So that is my domain. All right, last example of this. F of x equals the square root of x squared minus 20. So again, I'm going to go graph it. Sorry, I don't know what happened to my voice. I graph it, and it looks like that. Does this pass my horizontal line test? It does not pass my horizontal line test, and since it doesn't, there is no inverse function. No inverse function. You can find an inverse, but the inverse is not a function, and that's what we're doing right here. Okay? So, as I said, when you have inverses of each other, they undo each other. So whatever you start off with, okay, if I go back up to this one here, I start with this, and I put it in a function, and then I put it back in the inverse function, I'm always going to get what I started with. Okay, that's what's going on in this next concept of the composition of inverse functions. If I compose two functions and I get x, then I know that there are inverse functions of each other. Okay, that's as simple as this. So we're just going to go show that algebraically. Okay, and when you do this, y'all, this is like a proof in geometry. So what's most important is all the steps that you do. It's not that you just say yes or no. It's you got to show me the steps. Prove it to me. Okay, so this actually said f of g of x that you have to do both of them, but I'm telling you, you don't. In all my years of doing this, I have yet to run across a function where it came up to x for one and not the other. So you can do both if you want to, but I just thought I'd save you a little bit of work. So you do have to tell me. So what you're going to do, if you decide to do f of g of x, okay, so I do f of g of x, then that means that g of x is on the inside. So I'm going to replace what's on the inside with g. And g is 6 minus x over 3. So that's what's going to go inside my parentheses. All right, the next step says I'm going to put in for f. Well, I'm putting this inside into f. So what is my rule for f? Well, my rule for f says 18 minus 3 times whatever you have in parentheses. And what's in my parentheses is g, which happens to be 6 minus x over 3. This next step. So all of these steps are critical, y'all. This, you've got to show me the math of distributing that 3 or negative 3 through your parentheses. So I get 18 minus 18 plus x. Well, when you simplify that, guess what you get? You get x. So that means that f and g are inverses, because when I compose them, I got x. Okay? And that's all you got to do. 3b. F of x equals x squared plus 10 for x greater than or equal to 0. G of x equals the square root of x minus 10. Are they inverses of each other? So this time I'm going to do g of f of x. It does not matter which one you do. You just got to do it correctly and show the work correctly. So I start on the inside. F of x is x squared x squared plus 10. Okay, so I'm going to have g of x squared plus 10. Now, what does g say to do? G says take the square root of whatever you have in parentheses and then subtract 10. So I'm going to have the square root of whatever I have in parentheses minus 10, and what's in my parentheses is x squared plus 10. So when you simplify that, those 10s fall out, and I'm left with the square root of x squared, which is the absolute value of x. We've talked about that. That's the even, odd thing that we just had on a previous video. So I have to have those absolute value things. Well, that's what's so important about that right there, because it says x is always positive. X is greater than or equal to 0. So if my absolute value, I only want the part where x is greater than 0, well, then that means that when I compose them, it will be x. Therefore, f and g are inverses. Okay? So the last one you have, these are the most fun because I just think they're easy, but I really love the way Delta Math does these problems. So use the graph of each function to graph its inverse. Like I said, you're going to like it because it's easier than what we just did algebraically. The key, okay, if you have the point AB, then you have to have the point BA on the inverse. I'm going to go and write that. So if I have AB on one function, then I'm going to have BA on the inverse. So what am I going to do? This blue line is the original one, y equals f of x, and to graph its inverse, I'm going to go find points on here. So this one right here is at 0, 3. So that means I'm going to have 3, 0. Boom. There's 3, 0 right there. Okay, so I'm going to find another one. Here's a point right here. This is at -1, +1. So -1, 1 means I'm going to have 1, -1 because I'm going to switch them. There's a little off there. Okay, and here's another one. This is -2, -1. -2, -1 means I'm going to go -1, -2. Okay, and look at that point. This was -3, -3, which is -3, -3. And remember, I told you they will always intersect on that line y equals x, or they're going to intersect y'all at the point where the coordinates are the same. Okay, so in Delta Math, you actually have to have 5 of them, but you just go find that point and switch it. If you want to write it down, you can. But obviously thought this was easier. Okay. So this last one, I have this graph here, this skinny blue graph. Well, it's got the point 0, 0, so I'm going to have 0, 0. And then I'm going to look for a point that's easy to graph, and I'm going to say that 30 and about halfway up. So about halfway over, I'm going to go up to 30, which is about that one. And then I'm going to graph another one. Like I said, it's a little bit easier somewhat in not ClassCalc, Delta Math. Too many things. So if I go to 70, I'm really close to that first one. So if I go really close to that first one, I'm going to go up to 70. And that is all you have to do to graph the inverse function. So I hope you see that's pretty easy and good to go. All right, I hope that helps. If you have any questions, please don't hesitate to email us or come see us. Thank you so much, and y'all have a great day.